Hello. Hello. Am I clearly audible?
Yes, sir.
Yes, sir.
I'm sorry for the delay. Let's start our today's lesson. In our last class, we have started discussion on random forest, and we have already discussed a part of it. In our last class, we have considered this data set, and then we have constructed the decision tree. Specifically, we can say considering the numeric values of the variables. And we have constructed this decision tree in our last class. Now, in this lecture, I want to continue the discussion on random forest. But before that, I want to discuss about another topic that is called the regression tree. Okay? The concept of regression tree, that is, it's one kind of regression. And then what actually we do in regression? We try to analyze, that is the kind of the estimation between dependent variables and independent variables. So that's what in statistics we call it regression. Okay? That means if we have some variables, like maybe we can say some variable like maybe you can say hours of a study, okay, hours of a study. And another variable is maybe consider the GPA. Then we can collect the data from maybe many students for a definite course or maybe for their entire semester. The hours of a study for maybe student 1. And hours of a study, maybe you can say daily hours of a study, maybe the 7 hours. And then we record his or her CGPA or GPA on that semester, Maybe you can say like 7 hours of a study got 3.56. Then another student like S2, the hours of a study, maybe we can consider the 12 hours per day. And then the GPA, maybe 3.88. And maybe student number 3, hours of a study, it is 16. And for that case, maybe 4.0. So in this way, we can collect the data from different students. Maybe you can say student number 1000, and then hours of a study, maybe you can say it is 8, and the corresponding GPA maybe 3.9. Okay, so now we can see that is if we consider about just 2 variables, so hours of study, and we want to predict the GPA. Okay, GPA. Then what we have to see that here the GPA, these are actually numeric values. Those are numeric values. Sorry. So we can see all these are just numeric values. And actually, we want to predict those numeric values based on maybe some other students. Like if we consider about student number, maybe 2000. Student number 2000, we know the hours of study of this student, maybe you can say 7.5 hours per day. Then what will be the predicted GPA for that student? So in this case, the predicted GPA, we can see those are actually continuous values. Okay, continuous values instead of just only, we can say, some categorical values. We can see that actually those predicted values will be continuous values. So if any data set we can see that the prediction or predicted variable values, maybe we will get some numeric values on that case, numeric values or maybe decimal points also. So on that case, we need to think about, like, we have to apply some regression method to find out those specific predicted values. So what actually we can see in this case, we want to find out a relationship between the hours of study and also GPA. So that's why in regression analysis it is mentioned that in regression analysis, it's a set of statistical method used for the estimation of relationship between dependent variables and one or more independent variables. So the GPA, we can say here GPA and GPA and hours of study. Sometimes maybe not only hours of study, maybe some other factors can be considered for that. So that's why it is mentioned about one or more independent variables. So in this case, just only one independent variable is hours of study, and GPA, it is depend on that. There's a GPA, it is depend on the hours of study. So we can consider that the GPA is our dependent variables and hours of study is independent variables, or we can consider more independent variables also. So we will see it in our some other examples. So now the regression, it can be linear, it can be non-linear, it can be multilinear. So basically, we can divide the regression problem in linear and non-linear. So like if we consider about this data set, so we want to predict the IQ score based on maybe these features. One is age and another one is place of living. So based on these two features. So if we want to predict the IQ score based on these two features, age and place of living, then at first we need to see that is what will be our predicted value. The predicted value, it can be the IQ score, it can be 1, 2, 3, or maybe even 4.5, maybe 2.3. Okay, so we can say those are continuous values. Okay, so those are numeric values and continuous values, floating point numbers. So that's why at first we need to think about, okay, maybe we need the regression algorithms to predict the actual values. Now, the next thing we have to consider that whether the regression algorithms we want to use is it the linear or maybe non-linear. Then for that we need to do some EDA, that is exploratory data analysis. Let's say we want to plot this one, that is S versus IQS. So here this is the parameter. Okay, so this is the feature S. So A is feature and the IQ score. So if we just plot this A versus IQ score, this is a scatter plot. Actually, age is 8 and IQ score is 1. So here we can see that the 8 and maybe IQ score is 1. So this is the data point. And then next is 10 and maybe 3. So here is the 10 and then 3. And then 12 and 1. So here is the 12 and 1. Okay, 12 and 1 is this. And 10 and 3 is this one. Okay. And then 30 and 4. So here is the 30 and 4. This is 4. So this is the data point. Similarly, we can plot all those data points. So this kind of plot is usually we call it the scatter plot. So if we just plot using the scatter plot, then we will get the data points like this way. So now think about like if we can see that is the those data points, they follow just a trend line, the straight line, like you can say kind of a straight line like this. If the data points follow, and you can see there is you can see it like it follows maybe a trend line, then you can think about like just only the linear regression for modeling that kind of data. But if we can see there is actually it's not following a trend line, but maybe you can see if we can draw some polynomial like this way, then maybe that is better fit to that line. Okay, so if you can see this kind of curvature or curve, then you have to think about like we have to apply maybe nonlinear regression, regression mechanism. There are several nonlinear regression methods, polynomial regression, support vector regressor, and also today we will discuss one of the nonlinear regression method that is called the DC regression tree. Regression tree. So regression tree. In regression tree, we will actually draw polylines, or we can say multiple line segments. So that's why this kind of regression is called the regression tree. Why? We can see that is actually in our data points. If we can see this is age versus IQ score, we have maybe this is one trend and maybe another trend. If we can draw like this way, 2 line segments, then that will be better representation of this data set. And that's why we will select some nonlinear regression like the regression tree. Okay, then we have decided to, okay, we need some nonlinear regression. There are several nonlinear regression, but in this case, we want to apply the regression tree. Okay. The next, we need to think about like how many independent variables we have. In this case, we can see we have 2 independent variables. One is age and place of living. That means based on these 2 features, we want to predict the IQ score. Okay? Predict the IQ score. So let's say this is actually the training set. So that means we have 6 instances. All those instances we want to apply for training purpose. Okay, training purpose. Consider this one is just a training set. Then next thing we need to think about like how to deal with each and every feature values. Then here is the age feature and place of living feature. So age, we can see it has the numeric values, okay? 8, 10, 12, 30, 35, and 60. But place of living, it has place of living is village and city. That means 2 types of place of living. So it is categorical variable values. Categorical variable values it has. So we need to deal with both the numeric values and categorical variable values. So now consider the age first. Okay? Age, that means this one, numeric values. Then how to deal with the numeric values? There are several ways, but the popular we want to deal. We want to learn the popular ways to deal with the numeric values because you can think about the quantization maybe you can say the age 8 to 12, those are maybe child, and 30 and 35, maybe you can say the adult, and maybe 60 plus is old. So that type of quantization sometimes you can do, but that's actually uh, not the proper or right way, because sometimes it's difficult to uh, quantize for each and every variables. Like there are several values, and it's difficult to quantize. Okay, so that's why the numeric values, whatever it is, we can also develop our regression tree dealing with those numeric values. Now consider here is A's. These are the A's and our IQ score. So to deal with the numeric values, what we have to do, we have to at first sort our data set based on this S parameter. In our last class, we have already discussed about a little bit about it, because when we have constructed the decision tree for x1 parameter and for x2 parameter, x1 and x2, those variable values are also numeric values. And what we have done, that is, at first we sort the data based on x1 when we intended to that is deal with the x1. Similarly, here is also the same thing. Like at first we want to deal with the A's, so we need to sort the data like ascending order here, 8, 10, 12, 30, 35, and 60. Okay, ascending order. And luckily we can see actually it is already sorted. So that's why we can take those 8, 10, 12, 30, 35, and 60, and the corresponding IQ score. Those are corresponding IQ scores. Now, as we have done in our last class, similarly, we also try to do the same thing. Like we have to find out the average of two consecutive numbers. 8 and 10 is 18, the average is 9. And then 10 and 12, this is total 22, the average, it will be 11. Okay? So 11. And 12 and 30, there is our 42. The 42, the average is 21. Okay? Average is 21. So in this way, we have to find out the average of two consecutive numbers. Okay? Average of two consecutive numbers. So these are the average of two consecutive numbers. 8, 10 is 9, 10, 12 is 11, 12, 30 is 21, and 30, 35 is 32.5, and 35, 60 is 47.5. So at first, we have to find out the average of consecutive numbers. Then again, we have to do the same thing as we have done in our last class. That is, we have to think about like 9 as the splitter, 11 as the splitter, 21 as the splitter, 32.5 as the splitter, 47.5 as the splitter. Okay. And considering the 9 as the splitter, then what we will get if we consider the 9 as a splitter. Okay? So let's say we have the data set. So this is our data set, and we are considering 9 as our splitter. So 9 as our splitter. Now, if we consider 9 as our splitter, okay, considering 9 as the splitter, so the age less than or maybe less than equal 9. So this is our splitter. So on that case, what we have to do, to pass our first instance, the observation number 1. Okay? Then we can see age is 8 for that case. So 8. Whether this one is true or maybe false. Whether this condition is true or false. So the first observation, for the first observation, the age is 8. Age is 8. So So this, if age is 8, that means 8 less than equal 9. This is true. Okay? True. So first observation, actually we have to place in true side. So true side, we have the first observation, observation number 1. And then we have to pass the second observation, and we can see the age of the second observation is 10. So here is 10. If we consider 10 less than equal 9, no, actually false. So that means the observation number 2 we have to place in false side. Similarly, if we consider the 3, okay, 3, what's the age? Age is 12. If age is 12, then again, if we pass the 12, then 12 less than 9, this is not true, so this is false. So we have to think about observation 3 in false side. Okay. Similarly, observation 4, actually 30 is 30, so 30 is not less than 9. So observation 4 we have to consider here. Observation 5 also 35, so 5 will be here. And observation 6, that is 60, so it will also be in false side. Okay, so if we consider as 9 as the splitter, then in true side we will get just one observation, only one observation here, that is 1. And in false side we will get, that is 2, and then 3, observation number 3, and then observation number 4, and then observation number 5, and also the observation number 6 in our false side. Now what we have to do, the observation number and the corresponding IQ score we have to consider. For the observation 1, the IQ score, corresponding IQ score is what? Corresponding IQ score is, for observation 1, we can see corresponding IQ score is 1. So the corresponding IQ score is 1 for observation number 1. And for observation number 2, the corresponding IQ score is 3. For the observation 2, the corresponding IQ score is 3. And then for observation number 3, the corresponding IQ score is 1 again. For observation number 4, corresponding IQ score is 4. And observation number 5, the corresponding IQ score is 5. And how about 6? 6 is also 2. Okay. So these are actually the IQ scores of different observations or different instances or different subjects. Okay, now what we have to do, we have to so these are what? These are our IQ scores. Okay, IQ scores of different observations. Okay. Now we have to find out the average of the true side, IQ scores of true side, and IQ scores of false side. So we can see average IQ score. If we want to find out the average IQ score. Hello.
Hello. স্যার আবার একটু যদি হ্যালো
হ্যাঁ বলেন।
স্যার ইগো আবার একটু যদি ব্রিফ করতে, মানে 2 এর অবজারভেশন যেটা 3, এটা কিভাবে একটু কাইন্ডলি যদি আবার ব্রিফ করে দিতেন।
আচ্ছা, ওকে। Okay, you can see there is observation number 2. The corresponding IQ score here is 3. Okay, and then observation number 1. The corresponding IQ score is 1. Okay, so that's what we have written. Observation number 1, the corresponding IQ score is 1. And observation number 2, corresponding IQ score is 3. Okay. Similarly, observation number 3 and the corresponding IQ score is 1. Yeah. So this is how we have written these observations and corresponding IQ score. Clear? Is it clear?
Yes, sir. Clear. Yes, sir.
So now the next thing is we have to find out the average IQ score of true side instances and false side instances. So average IQ score. So we can see in our true side, we have just only one observation and then IQ score that is 1. So if we if we just try to find out the average of that, then we will get the 1. Actually, the average is 1. Average is 1. But in case of the false side, we can see that we have total 1, 2, 3, 4, 5. So 5 instances here. So that means we have to find out the average. Then 3 plus 1 plus 4 plus 5 plus 2. So we have to sum up all these and then divide it by 5 to get the average. In this case, we can see 3 plus 1, 4, 4, 4, 8, 8, 5, 13, 13 and 2, 15. Okay, so 15 by 5, that is 3. Okay, 15 by 5 is 3. So that is in this side, if we want to find out the average of these 5 instances, then we will get it is 3. Okay, 3. So these are actually the average A, B, G, IQ score. Average IQ score. Okay, average IQ score. So considering the S9 as the splitter, we can see that is in true side, we got just 1 as the average IQ score, and right side, in this case, we can say false side, that is the right side. So in this right side, okay, so false side actually we can say it is in right side, and this one is in left side. Okay? Left side. So average IQ scores of false side or right side instances, we got 3, and left side instances or true side instances, we got 1. So now I think you know that the average is the simplistic prediction. Okay, average is a simplistic prediction. That means if we want to predict someone's maybe age, maybe the age of this class of students, then maybe a new student just join in this class. Then how can we predict the age of that student? Just do the average. Okay, just do the average of the previously enrolled students, and then make the prediction. Maybe the age will be within uh, within 24 or 25, like this. Okay. So this is how we can predict uh, the, the variable. So we can assume that actually if age is less than 9, then the prediction of the IQ score, that is 1. And if age is greater than 9, then the IQ score will be 3. So this is the simplistic prediction. Okay, simplistic prediction, and that's why we have just maybe find out this splitter. Okay, this splitter. But now we just assume that okay, if age is less than or equal 9, then IQ score, the predicted IQ score will be 1, and if age is greater than 9, then predicted IQ score will be 3. But we know that actually this prediction will not be perfect. Okay, so that's why what we need to do, we need to find out the quality of our predictions. Okay, we need to assess our prediction model. So if we want to assess the prediction model, then what we have to do, we can apply some of the there is loss functions. Okay? We can call it loss function or error functions. Error functions for measurement of the errors in our predictive model. So for that, if we consider about, okay, we want to find out the error using like, there are several loss functions, mean absolute error, mean absolute percentage error, sum of square residuals, and cross entropy loss. So those are actually, we can utilize here for any of the loss functions. But in this lecture, I have utilized the sum of square residuals. Okay, the sum of square residuals as a loss function, or you can say error function. Okay, to measure the errors of our model. So now we can think about, like, if we have if we have this prediction. Okay, so if we consider this is our splitter, then what will be the error in this case? Okay, what will be the error? So now we have to so we want to use the sum of square residual, that is called SSR. Okay? We want to calculate the SSR for this model, for this splitter, for this model. So for the left side, we can see if the age is less than or equal 9, then the prediction is 1. And if it is greater than 9, then we will consider the average IQ square is 3. But what's the actual value? So in our data set, we can see these are the scores. Those are actual values. Okay, actual IQ score. So actual IQ score of observation 1 is 1. Observation 2 is 3. Observation 3 is 1, like this way. Those are actual values. But we have considered this one as our predictive model. And in this case, we can see actually it is different. Okay? It is different. And now we want to find out we want to assess our model. So for that, we want to utilize the sum of square residual loss function, okay? Loss function or error function, or error measurement function. So consider that the first observation, for the first observation, we can consider the first observation. The actual value IQ score is 1. Actual IQ score is 1. So here, just write that for the observation 1, actual IQ score is 1. Then what's the prediction? What's the prediction? Prediction is for observation 1, if we pass this one to our model, then we can see the age is 8 on that case. Age is 8. So if we pass this one in our model, in this model, pass the 8 here, 8 here, we can see it will predict that, okay, 8 less than 9, yes, then it will move in this direction. And we can see the prediction is actually 1. The prediction is 1. So the predicted IQ score will also be 1. Then the original IQ score minus predicted IQ score. And then this is called the residual and square residual. The residual is the original minus prediction. Okay, so original minus the prediction. The prediction. This is called the residual. This is called residual. Then square residual is a square of value of that. Okay, so that is our square residual. Square residual. And then we have to sum up for all the cases. Okay, so that is, we have to do the summation for all the instances, and that's why here is plus. Okay, so for the first observation, you can see the original IQ score is 1 and predicted IQ score is also 1. Then think about our observation number 2. Observation number 2, in this case, we can see for observation number 2, the original IQ score is what? Original is 3. Original is 3. So we can write it here. Original IQ score is 3. Then we have to see the prediction. We have to see the prediction. So we have to pass this instance, so the observation number 2, pass this instance, observation number 2, and then we can see that it is 10. Okay, that it is age is 10. So if age is 10, if we pass it here, age is 10, and 10 less than equal 9. Is it true? No, it's false. So that means in this side, you have to move in this side. And in this side, we can say this side's prediction is 3. Okay, this side's prediction is 3. Prediction is 3. So here is the 3. Original is 3. Prediction is also 3 square. Then we have to check the third one. That is our third observation. And original is 1. Original is 1. So we can write for the third observation, original is 1. And then what will be the prediction? So that means on that case, we have to pass the third instance, this instance, to our model, and the age is 12. If age is 12, that means if we pass the 12 here, the value 12, then it will be, that means is 12, is it less than 9? No, so it's false. So again, we have to move in this direction, and you can see prediction for that is actually 3. The prediction for that is 3. Okay? So that means 3. The original IQ score is 1, but the prediction is 3. Now we have to consider the fourth observation. So here is the fourth observation, and then the original IQ score here, it is 4. Okay, so we have to write this is 4 minus, and then we have to predict this one. Okay, so now for observation number 4, the age is 30. So we have to pass the 30 here. So if we pass the 30, then we can see this is not actually less than 9. So we have to move in this direction, false. And we can say in false side, the average IQ score is 3. That means prediction is 3. The prediction is 3. Now check the next one. That means observation number 5. So the observation number 5, the original IQ score is 5. Original IQ score here is 5. And then we have to think about now the prediction. So we have to pass this instance in our model. So it is 35. Okay, here is the 35. So pass the 35 here. Then we can see the 35, that is it's greater than 9. So that means again the false side. So that means the 3 will be the average IQ score. So that means the prediction is 3. Okay, then a square plus. Then we have to think about this observation number 6. Observation number 6, the original IQ score is 2. So here is 2. And then the prediction for 6, we can see the age is 60. So 60 is, if age is 60, if we pass it here, 60, then again this one is greater than 9, okay? Not less than 9, that means false. We have to move in this direction, and we will get 3. Okay, so here is the 3. So now the square of it. So this is the SSR, that is sum of square residual. We have considered all the 6 observations. Okay? All the 6 observations. Now we can see this is 1 minus 1, it's 0. Square value is also 0. And then 3 minus 3, the 0. Square value is also 0. And then 1 minus 3 is minus 2. Minus 2 square is 4. Then plus 3 minus 4 minus 3, that is 1. 1 square is also 1. And then 5 minus 3, 5 minus 3 is 2. 2 square is 4. And then plus of 2 minus 3 is 1. So 1 square is 1. So now 4 for 8 plus 2 is 10. Okay. So that means sum of square residuals for this predictive model, that is less than equal 9. This splitter is 10. This splitter is 10. So that's what we have written here. So if we consider our consider S9 as the splitter, then sum of square residuals will be 10 for that case. Okay, square residual will be 10. And average IQ score of left side, that means we can say true side instance. We have already seen it is 10. It is 1. And average IQ score of right side instances, that means the false side instances, that is 3. So we have just maintained this one as a tabular record. Tabular record for each and every splitter. So for if we consider S9 as a splitter, then this will be the case. Okay. So now similarly, what we have to do, we have to think about our next splitter. The next splitter is 11. Okay? Next splitter is 11. So we have to consider the splitter, that is splitter 11. So this is splitter. if we consider that is splitter, then again we have to find out maybe another prediction. So is now less than 11. Considering this as our splitter, again the condition will be true, or it can be maybe false. It can be false. Now again we have to pass our data set, like this data set. We have to pass our data set to our model. So considering our the first one, so observation number 1, considering first one, so is 8. Is here is 8. The corresponding IQ score is 1. Okay. So at first is 8. If we consider is number is 8, the first observation, 8 less than equal 11. Is it true? Yes, true. So observation 1 we have to place in two sides. Then think about the next observation, observation number 2. The age is 10. Okay, age is 10. Observation number 2, age is 10. Is 10. 10 less than equal 11. Is it true? Yes, it is true. So that means we have to place observation number 2 here. Then next we need to consider the next, that is observation number 3. So here age is 12. Age is 12. 12 less than 11. Is it true? No, false. So we have to place it in false side. So observation number 3 in false side. Then next one is observation number 4, and age is 30. Is 30 less than 11? Less than equal 30 less than equal 11. Is it true? No. So that means false. So we have to place it here in false side. Now think about our next observation, that is 5. 5 is 35. Is 35 less than 11? No. So we have to place the observation 5 in false side. Then the last one is 60 here. Okay, 60. We can see place of living. Sorry, is 60. Is 60 less than 11? Is it true? No, false. So that is 6. We have to place it here. Okay. Now considering that, we have to now write the corresponding IQ score. Observation 1, the IQ score is 1. IQ score is 1. And observation 2, IQ score is observation 2, IQ score is 3. And how about the IQ score of 3? IQ score of 3 is 1. And how about 4? 4 is 4. 5 is 5. So 4 is 4. Then 5 is 5. And the 6 is 2. Okay, 6 is 2. So these are the IQ scores. Okay, these are the IQ scores. Okay, so these are the IQ scores. Now we have to find out the average IQ score of true side and false side. So if we find out the average IQ score of true side, then we will get 1 plus 3 divided by 2. It is actually 1 plus 3 is 4. 4 by 2 is 2. So we will get 2 here. Okay. If we just find out the average of these 2, then we will get 2. Similarly, we have to find out the average of our IQ score of our false side instances. Okay. So in this case, we will get 1 plus 4 plus 5 plus 6 divided by 4. So here is 5 plus 6, 6, 6, 12, 12 and 4. 12 and 4 is 16. 16 divided by 4 is 4. Okay, 16 divided by 4. Am I right? 1, 2, 3, 4. Yes. 4.
Sir, the last one was 2, not 6.
Okay. That's 2. Thank you for the correction. Okay, so that means it's 2. Now you can see it is 5, 5, 10 plus 2. So that is 12 divided by 4. It is 3. That is 3. Okay. So these are actually the average. Okay, average IQ score. Average IQ score. The average IQ. These are the average IQ score. Now again, we have to find out the SSR. Okay, SSR for this prediction. Actually, if we consider this is splitter, then whether it will be better than the previous one or not, we need to find out that. So that's why, again, we have to pass our data set. That is observation 1. The original IQ score is 1. Original IQ score is 1. Original IQ score is 1. And the prediction, what's the prediction? If we pass this one to our model, that is S is 8. If we pass this one to our model, here, we pass 8 here. Then we can see it is 8 less than 11. That is true for this side. So that means observation 1, so this side's average IQ or predicted IQ is 2. Okay, so here 2. This is the prediction. And then original is 1. 1 minus 2 square. Okay. The next one, that is the observation 2. We can write actually everything from this figure. For the second observation, this is actually our second observation. So this is our second observation. The second observation, IQ score is what? IQ score is 3. Okay, IQ score is 3. And then what's the prediction? Prediction is 2. Okay, prediction is 2. So 3 minus 2. Then we need to think about our third observation. This is the third observation. This is the third observation. And then corresponding IQ score is this. This is the corresponding IQ score. Okay, third observation IQ score is this. And then what's the prediction? The prediction is 3. Okay, prediction is 3. So this is 3 plus the next one. The next observation is 4. First, the original IQ score. Original IQ score is 4. Original IQ is 4. Then minus. What's the prediction? Prediction is 3. Prediction is 3. Plus the next one, that is observation number 5. Original IQ score is 5. So here is the 5. Then what's the prediction? Prediction is 3. Okay, prediction is 3. So here is the 3. Then whole square plus the next one is observation number 6. Original IQ score is 2. So here is the 2. Then what's the prediction? Prediction is 3. Okay, prediction is 3. And then take the square of that value. Okay. So now we have to find out the SSR. 1 minus 2 is minus 1. So 1 square is 1 plus 2 minus 3 minus 2 is 1. Then 1 square is 1 plus here is 1 minus 3. That is negative 2. Negative 2 square is 4 plus 4 minus 3. So 1. 1 square is 1 plus and 5 minus 3 is 2. 2 square is 4 plus 2 minus 3 is just negative 1. Negative 1 square is also 1. Okay, so what we will get? 4, 4, 8, 9, 10, 11, 12. So we will get 12. So error, you can see this is the error. 12 is the error. And previously it was 10 is the error. Okay, 10 is the error. So that means actually this is splitter. That means first is splitter. This is splitter is better than the second one. Better than second one is less than equal 9. If we split like this way, then we will get the less error. Then is less than equal 12. So in this way, what we have to do, we have to find out for each and every splitter. Find out the SSR for each and every splitter. Like we have already discussed about 9 and 11. So considering as 9, we got the 10. Considering as 11, we got the 12. Okay, we got the 12. Similarly, if we consider as 21, as I already mentioned, we have to think about is a splitter. Like if we consider a splitter less than is less than 21, then is less than 32.5, is less than 47.5. Okay, and we can see for is less than 21, the sum of square residuals will be 7.33. Okay, and then if we consider is 32.5 as a splitter, for that we will get 11.25. If we consider 47.5, then we will get 12.8. I think no need to discuss each and everything, because I have already discussed two. Similarly, you have to find out the sum of square residuals for all other cases, all other considerations. Okay. Now, after that, after getting the sum of square residuals for all possible splitters, what we have to do, we have to find out the lowest sum of square residuals. Which one is the lowest? Now we can see this one is the lowest, the 7.33. Okay, 7.33 is the lowest sum of square residuals. Specifically, this sum of square residuals we got from is less than equal is less than equal 21. Is less than equal 21. This is splitter. Okay, is less than equal 21. Considering is 21 as the splitter. So that means if we consider is feature to construct that regression tree, as regression tree is also one kind of tree, so we need to find out the root. So that means if we consider the as feature on the root, then we have to consider the as less than 21. This feature, this one at the root of our regression tree. Okay, at the root of our regression tree. So that means that's why which splitter of A's will be better. So that one we have already find out, and then we can think about, like if we consider A's as our splitter, then we have to consider A's less than or maybe equal 21 as our splitter, okay, from the A splitter. So already A's we have considered. The next we have to think about if any other parameters we have. In our data set, we have also another parameter. So this is called the place of living. Okay? Place of living parameter. The place of living, now we have to deal with this parameter. There is place of living, this feature, okay, this feature. And now we can see it's actually the categorical feature values. Place of living, two types, village and city. So we have to deal with a little bit differently, okay, little bit different. So for that, the place of living and corresponding IQ score, we have to consider just this part, okay, place of living and corresponding IQ score. Again, we have to think about our place of living feature. The place of living, if we consider place of living, this one equal maybe village, okay, village, this one as our splitter. Place of living equal village. Again, we can see whether this condition is true or maybe this condition is false. We have to consider like this way. And then from the data set, the place of living and corresponding IQ score. The place of living and corresponding IQ score. Okay, so you can see place of living and corresponding IQ score. Now, if we consider the observation number 1, okay, so we have to consider place of living and IQ score. Then for the observation 1, the place of living is village. Okay, place of living is village. We have to check it here. For the observation 1, the place of living is village. Observation 1, if we pass, then place of living will place. Is it true? Yes, true. So that means observation 1, we have to consider here in true side. And then the next, we have to consider the observation number 2. Observation number 2, this is the observation number 2. And then corresponding place of living is city. Observation number 2, corresponding observation number 2, corresponding place of living, is it village? No. So that means observation number 2, we have to place it here. Then think about our next one, that is our observation number 3. Observation number 3 and place of living is village. Okay, so place of living is village. We have to place observation number 3 here on this side. And then how about the 4? Observation number 4, place of living is village. Okay, so again we have to think about it is in true side. So that means 4 is also in true side. And observation number 5, place of living is city. Yeah, so city, that means it's in false, and place of living is city, so we have to place it in false side. Similarly, we have to think about like the last observation, the observation number 6, place of living is city. Okay, so we can place it city, so that means it's false. The 6 will be here in false side. Now we have to write the corresponding IQ score. For IQ score of observation 1 is 1, and then 2 is 3. Okay, observation 1. Observation 1 is 1, then 2 is 3. So 2 is 3. And then observation number 3, 3 is 1. So 3 is 1. Then observation number 4, 4 is 4. So 4 is 4. 5 is 5. And then 6 is 2. Okay. So now what we have to do, we have to find out the average. Okay, average of this side, average of true side instances is 1 plus 1 plus 4. So that means 6 by 3. 6 by 3 is 2. So the average is 2. And then we have to find out the average of this side. So it's 5 plus 3, 8 plus 2 is 10, 10 by 3. Okay, 10 by 3. It is 3.67. Okay, 3.67. Now we can see these are actually our average IQ score. That then, as I have already mentioned, the average IQ score will be the predicted IQ score, because most simplistic prediction is just average. So average IQ.
Sir, it should be 3.33.
Oh, 3.33.
Yes, sir.
5 plus 5, 10, 10 by 3. Okay. Yes, 10 by 3. 3 point. 3, okay. Maybe. Yes, it is 3.3. 3.33. Okay, so 3.332, and then average accuracy score 3.3. Now, the next thing is we have to find out the sum of square residual, okay, SSR. If we consider the SSR, then again for the first observation, this is the first observation, the IQ score is 1, original IQ is 1, minus the prediction is what? Prediction is 2. Prediction is 2. Also, plus, then the next one is, you can say 3. No, the next one is 2. Next one is 2. The 2 original IQ score is 3. Original IQ score is 3 minus prediction is 3.3. Okay. So here is, and then next is 3. So 3 is our 1 minus 2. Okay. So similarly, we have to think about next one. 3 is 4. Okay. 4 is 4. So 4 minus 3.33. Okay, 33 square. And then plus,
Sir, 4 minus 2 হবে না sir?
4 minus 2 হবে, হ্যাঁ ঠিক বলছো, 4 minus 2 হবে. Here is the 4, and the prediction is 4. So the original IQ score is 4 and predicted IQ score is 2. Okay. Then think about 5. 5 is 5. So here is the 5 minus. The prediction is 3.33. Okay. 3.3 whole square. The next one is our 6. So 6 is 2. It is 2 minus this one, 3 minus 3. Okay. Whole square. Then if we do the math, then we will get the sum of square residuals. Okay. I think I have already calculated it here. Why is that? Okay, here. Considering place of living equal village as the separator, okay, as the splitter, you can see we will get 10.666. Okay, so it will be 10.666. That means 67. 10.67. Sum of square residual will be 10.67. Now we have to think about our data set again. In our data set, the place of living and IQ score. So this part we are considering. The place of living, we have already considered one, that is the place of living equal village. Now we have to consider place of living equal city. So city is C. Again, what we will get? We will get the true side and false side. So now we have to pass our data set again. Observation 1, we have to pass to our splitter, and here the place of living equal village. We can see if we pass the village, is it true? No, false. So that means observation 1 we have to place in this side. And then the second observation we have to pass to, then place of living equals city. So for the second observation, the city, yes, place of living the city. So observation number 2 we will get in this side. And then the third observation we have to pass. Again, this one is village. The village, if the village, then it is false. Okay, so observation number 3 we have to write in false side. Then the next one, 4. So again village. Again village. So village, that means place of living city, not true, not true. That is false. So we have to write the 4 here. Then for the 5, it is city. For the 5, it is city. City is true. So 5 we have to write here. And how about the 6? The 6 is city. Okay, 6 is city. So 6 city, that means we have to write it in true side. So 6 will be in true side. Now actually what we can see, if we look here, or if we observe closely here, between these two trees, so we can see in true side, in this true side, we got 1, 3, and 4. And in this false side, we got the 1, 3, and 4. That means these instances we got here. And that means true side instances we got in false side. Similarly, the false side instances, 2, 5, and 6, these instances, actually we got in this side. Okay, so this side. So true side instances we got in false side, and false side instances we got in true side. So this kind of tree, actually we call it the mirror tree. Okay, mirror. It's just the mirror of our first tree. So if we got the mirror, and that means we will get the same SSR for this one also. We will get the same SSR. So if we got something that is the mirror trees, then we will get the same SSR. So actually, for just only 2 variables, if we consider the place of living equal village, that means we also consider the place of living equal city, because it's just the opposite. Because we have just only 2 variables here. One is village, another is city. It is like the yes no. Okay, so like the yes no, 2 variables, binary variables. So that's why we will not consider, or we will not actually calculate the mirror trees, SSR of mirror trees. We will consider just only this. Okay, because the mirror trees also will provide us the same result. So that's why we can see here in regression tree construction, when we consider place of living, we have just considered the only one instance here. One splitter here, place of living equal village as the separator. And for that we got 10.67, the SSR, we got 10.67. Now find out the minimum SSR for place of living. The minimum SSR. Actually, we have just only one splitter here for our place of living. So we can consider that one is the minimum for place of living. Okay, minimum for place of living. So previously we have determined the age, and then we can see the considered splitter should be age less than 21. But for the place of living, the considered splitter should be place of living equal village. Okay? Place of living equal village. So this is splitter. Now we have to go back to our data set and find out if there are any other parameters or features in the data set or not. We can see we have already considered age and place of living, and there is no other feature in this data set. So now we have to find out that is the which feature and which splitter actually provide us the lowest SSR or lowest error. Okay, lowest error. So for the age, that is age less than 21, we got the SSR 7.50 here. Okay, 7.50. And for our place of living, there is place of living equal village, we got the SSR 10.67. So that means minimum SSR for age is 7.33 and minimum SSR for our place of living is 10.67. That means the lowest one is age. Lowest one is age. And actually the age less than 21. That is splitter. Okay, that is splitter. So now we got our root of the regression tree. Okay, that is less than or equal 21. We have to consider that one. That is less than or equal, maybe you can consider less than or maybe less than equal 21 as the root of our regression tree. Because we got that. We got this. Okay. So now we can see there is less than 21. This one is our the root of our regression tree. So this is the root. So now we got the root, and then for the yes condition, that is true condition, and then the false condition we have to consider about. So in the IQ score in left side, or we can say the true side. So this is the true side or left side, and IQ score of right side. You can see it is this is the predicted IQ score. Okay, predicted IQ score of left side. So left side is this is average IQ score is 1.67. For the right side, the average IQ score is 3.67. Okay, so here is the 3.67. Now the next thing is, okay, we got the root, and also if we stop here, instead of maybe considering the next level hierarchical instances, then on that case we have to think about like this is our prediction for the left side instances, and this is our prediction for right side instances. Okay? Right side instances. But what we have to do now, we have to check there is our conditions also. There are several parameters we can stop the construction of the tree. One of the stopping criteria could be there is the depth of our tree. So if we think about the depth is maybe just only one, okay, just only one, then we can stop here. Then if we consider we want to construct of more depth, like maybe the two, then we have to consider the construction of next hierarchical features. Okay, now if we consider, okay, we want to expand a little more. So for that, here this is our root. This is our root, and then this root actually will split our data set into two subsets. If we think about our data set, so this is our data set, okay, and we consider the age less than equal 21. So this one as our splitter, or we can say this is the root. This root will split our data set. We can say is 21. So is 21 means it will be between these two, okay, 12 and 30, between these two is 21. So actually, it will split our data set into two subsets. So like this one in one side, and then another one. So this one, okay. So one side we will get is less than 21. So is less than 21, that means 8 is less than 21, 10 is less than 21, 12 is less than 21. So specifically, that if we want to explore or expand the true side, then true side we have to utilize this subset of the data. If we want to expand our false side, then we have to utilize this segment of our data set. Okay. So that means as 8, 10, 12 will be in the true side, and in our false side we will get that is as 30, 35, and 60. Okay. 35 and 60. We want to expand. Okay, let's say at first we want to expand this side. That is the left side or true side. And for that, if we want to consider the true side, then specifically we will consider this data set. Okay? The age and IQ score and the place of living also. So here you can see 8, 10, and 12, this observation in true side, and these observations in our no side or false side. Okay? False side. So now consider if we want to expand this true side, then think about our data set. So this is our data set now. We have to consider this one as our data set. Now again, we can see that is our age and place of living. Age and place of living and corresponding IQ score is there. So again, we have to consider the age, and we can see age is our numeric value feature. This feature, it has numeric values. So we have to deal with the numeric values. Okay, so 8, 10, and 12. So I think we know how to deal with the numeric values, the feature of numeric values. So at first we need to sort and then find out the consecutive values of two numeric numbers. So here 8 and 10, the consecutive average will be, the average of the consecutive two numbers will be 9. And then the second one, here it is 10 and 12. Okay, for the 10 and 12, it will be 11. So that means we have to consider 9 as the splitter and 11 as the splitter again. So if we consider as 9 as the splitter, again, we can say is less than equal 9. This one is the splitter. If we consider then again, this is true side and this is false side. So we will get what? If we pass this data set to here, observation 1 is 8. So 8 less than 9, it is true. So here is the 1. And then observation 2, 10 less than 9, is it true? No, false. That means observation 2 will be here. And then again, observation number 3, if we pass it to our model, that is a splitter, then 12 is 12 less than 9, is it true? No, false. So that means observation 3 will be there. And then again, we have to find out the corresponding IQ score. The corresponding IQ score of observation 1 is 1. This is corresponding IQ score. And corresponding IQ score of observation 2, it is 3. And corresponding IQ score of observation 3, it is 1. We have to find out the average. The average of left side, it will be just 1. The average of the right side, it will be 1 plus 3, that is 4. 4 by 2 is 2. So it will be 2. So 1 and 2. Now we have to find out again the sum of square residuals. Okay, sum of square residuals. The SSR. So SSR will be in that case. So for instance number 1 or observation number 1, the IQ score, original IQ score is 1, and the predicted IQ score is also 1. Okay, so it is 1 minus 1 whole square plus for our observation number 2. So this is observation number 2. The corresponding IQ score is 3. So here is 3 minus of then what will be the average? Average is 2. That is prediction is 2. Okay, so square plus the next one is observation number 3 here. Corresponding IQ score is 1. and then minus of 2, okay, minus of 2, it is whole square. Then we will get the SSR, okay, we will get the SSR. So similarly, we have to find out the SSR of 11 also. You can see we have done it in tabular method. We are considering S9 as the splitter, then we will get the SSR is 2. Similarly, if we consider S11 as our splitter, then we will also get the SSR equal 2. Okay, so both of the cases, we got the same SSR, okay, SSR equal 2 and SSR equal 2.
স্যার এরকম টেবুলার ফর্মে লেখা কি ম্যান্ডেটরি?
No, mandatory now.
ওকে স্যার।
Okay, so we can see that then we have to think about our minimum SSR. Minimum SSR is what? Minimum SSR is 2, okay, because both are the same. So that means if we consider S feature, then we can consider either S less than equal 9 or S less than equal 11 as the splitter, okay, and minimum SSR we will get just only 2. Then as we have also another feature, there is the place of living feature. Again, we have to consider the place of living as our splitter. So if we consider the place of living, on that case, we can say again the place of living equal village if we consider this one as our splitter. We will get line two side. Here is true side and false side. Then the observation 1, place of living is village. If the village, then it is true. Yeah, so here 1. And then observation number 2, place of living village, no, this is false. So that means observation 2 we have to write in false side. Then observation number 3, place of living is village, that means it's true. So we have to write in true side. Again, we have to think about the corresponding IQ score. Corresponding IQ score of 1 is 1, and corresponding IQ score of 3, corresponding IQ score of 3, observation 3 is also 1. And then corresponding IQ score of observation 2, it is observation 2 is 3. Okay, observation 2 is 3. Okay, now we have to find out the average IQ score of true side instances and false side instances. For true side instances, average is 1 plus 1 divided by 2. So 2 by 2 is 1. Average IQ score. And then average IQ score of false side instances, we have just only one instance here. And that's why the average will also be 3. Okay? If we consider the 1 and 3, these are our just predicted IQ score. So now we have to find out the SSR for that. SSR for our place of living equal village. So for observation 1, you can see this observation 1. Original IQ score is 1. And predicted IQ score, this is the prediction. Predicted IQ score is also 1. This is also plus. And then for observation number 2, this is observation number 2. And then predicted IQ score is 3. Okay, so predicted IQ score is 3 minus, original IQ score is 3. Original is 3 and prediction is also 3. Okay, prediction is also 3. So 3 minus 3 whole square plus the next is I can see observation number 3. So here is the observation number 3 and original IQ square is 1. So here's 1 minus prediction is also 1. Okay? So prediction is also 1 whole square. So if we do the math, here's 1 minus 1 is 0, 3 minus 3 is 0, 1 minus 1 is 0. Actually, we got the 0. So that means sound test for residual, or we can say error, is 0 if we consider place of living village. So now, okay, 0. Now we have to compare. Okay, we have to compare. There is for minimum SSR for S, that is 2, and minimum SSR for place of living is 0. Okay. So what we have to consider that? We have to consider place of living. Okay, place of living. And place of living is equal village. The place of living village 0. Okay, 0. So here that means this side we have already expanded, and then we have to consider now the next level feature. We have to consider place of living. The place of living, if true, then this side, this is true or yes, and if false, then this side. Okay, this is false. Then we can see the left side, that is for the true side, the prediction is 1. So here the average is 1. And then for the right side, this is 3. Okay, so here the average is 3. Okay, average is 3. So that means in our case, we have the place of living will provide us maybe the 0. Okay, 0. Now we have to think about that is another branch, this part. Okay, this part. For this part, we have utilized the data set that is this data set. Okay? This data set, because this is actually all these ages are less than 21, less than or equal 21. If we want to expand this side, then what we have to do, we have to consider this data set. Okay, this data set. And on that case, we can see all the ages are greater than 21. Okay, so we have to consider this data. And again, we have to find out we have to deal with this age feature and place of living feature. So that means we have to sort based on the age in ascending order, then find out the average of 2 consecutive numbers. It will be 32.5, and then 47.5. 47.5. And again, we have to consider 32.5 as the splitter and 47.5 as the splitter. I have already calculated that. So here is 32.5 as the splitter. Okay. In that case, you will get the sum of square residual, that is 4.5. And then if we consider 47.5 as the splitter, then you will get 0.5. 0.5 as our sum of square residuals. So now we have to find out the minimum one. So minimum is 0.5, 0.54, which one? For 47.5 splitter. Okay. So the minimum SSR, if we consider is for this subset of the data, then the minimum SSR 0.5, and that is induced by this is less than 47.5. Okay. But again, we have another feature also, that is the place of living feature. Okay, place of living feature. Then if we have the place of living feature, then we have to consider it. The place of living feature, again, we have to think about the place of living equal village as the splitter, and then the true false. Okay, then we have to count the true false, and then we have to find out the SSR for that. Okay, so here is the place of living, and you can see the SSR you will get for that is 4.5. 4.5. So as just only one possible splitter for the data set for this segment of the data set. So this one we will consider the minimum for place of living. Okay, so minimum sum of residuals for place of living is 4.5. Now we have to compare between age and place of living. Place of living, we can see it is 4.5, but age, the minimum is 0.5. That means the lowest value of SSR we got from age feature now, age feature, and that is 47.5 splitter. The splitter, we have to consider 47.5 for that case. Okay, so we can write now here that is less than equal 47.5 in our right side extension. Okay? So if we extend the right side, then we can think about like the next consideration we have to consider is less than 47.5 splitter. And if we consider as 47.5 splitter, then the left side, or you can say the true side, IQ score is 4.5. So here is 4.5. And then another is 2. Okay, so here is the 2. So this side will be 2. Here is the 2. Okay, 2. Now if we combine both, then we will get this regression tree. Okay, at first we need to consider is 21, and then in this side, the true side, the next consideration should be place of living. And for that, if that is true, then predicted IQ score will be 1. If it is false, then the predicted IQ score will be 3. Okay? There is 3. Predicted IQ score will be 3. And then if the age is greater than 21, then we have to consider again the age, whether the age is less than 47.5 or not. If it is less than or equal 47.5, if this one is yes, then the predicted IQ score will be 44.5. Otherwise, the IQ score will be 2. Okay. So as our there is threshold for construction of the tree, we have considered like that is the depth. The depth threshold is 2. That means we will construct the tree of maximum depth will be 3. The maximum depth will be 2. So here you can see in this tree we have the depth 2. Okay, so that's why we can stop here in construction of our regression tree.
Sir, I have a question.
Yes, please.
Sir, on the true side of age less than 21, if we wrote place of living equals to city, would it be all right?
Yeah, it will be all right because two variables, either you can write city or village.
Okay, sir.
Okay, now we have constructed the regression tree. Now, as I already mentioned that if we consider that the data set, the given data set is for the training, okay, so that utilizing the training data set, we have already constructed our regression tree. Okay. Now think about the test case. The test case, like maybe any observation number 10 maybe. Then is for this observation is 34, and maybe the place of living is village. It is given. Village is given, and we want to predict the IQ score for this person. Predict the IQ score for this person. That means we can see that age is 34 and place of living is village. In such a case, what we have to do, we have to pass the query to our data set, to this data set, to our model. Okay, so this is the model we have built based on our training data set. Age 34 and village. At first, we can see in our model, it will check whether age is less than 21 or not. Is it less than 21? 34 is less than 21? No. So that means we have to move in this direction. This is no or false direction. So we have to move in this direction because the age is not less than 21. So then again, it will check what? It will check whether the age is less than 47.5 or not. Yes, 34 is less than 47.5. So we have to move in this direction. Okay. After that, we can see this is the leaf node in this case, and the predicted IQ score is 4.5. The predicted IQ score, we have to say the predicted IQ score for this query or for this test set, it will be 4.75. Okay, so that's the prediction. That's the prediction. So this is how the test case will work. Okay, the test case will work. Sorry, not the 4.75, it is 4.5.
So, sir, we can say that if the age is above 21, then the place of living doesn't affect.
Yes. According to this data set, whatever we got the in regression tree, It means that if age is greater than 21, the place of living on that case actually it doesn't matter. Okay.
Yes, sir.
And now, just last one thing I want to discuss about, that is for the case of the place of living, we have just two variables, two types of variable values. One is village and another one is city. So that's why we have considered maybe just only one splitter, the place of living equal village. If we can just take the place of living equal village, then it is equivalent to place of living equal city also. Okay? Because place of living city, it will create just another mirror of the tree. Okay, of the tree. So that means place of living, if here this side true side and this is false side. Actually, what it will do in true side, all the village people will be in true side, and all the city people will be in false side. Okay? For the two types of place of living. But now, if we consider that we have a little more, maybe we can say village, city, and capital city. Maybe capital city. Three types of village, city, and capital city. Then we need to consider at first, maybe you can say place of living equal village. On that case, the village people will be in true side, and then in false side we will get the city and capital city people. This one, and then again, if we consider place of living equal city, on that case, the true side and in false side. In the true side, we will get the city people, and in false side, we will get village and capital city people. Okay, capital city people. And actually, these two trees this time are not the mirrors. Okay, are not the mirror. These two trees are not the mirrors, because we can see in true side here is the village and here is the city, and in false side here is the city and capital city, here is the village and capital city. So these are not mirrors. So think about another one also, like if we consider about place of living equal capital city. In such a case, the true side and then in false side, okay? False side. So capital city people we will get in true side, and village and city people will get in false side. Okay, so this is also new. It's not the mirror of any of our previous trees. Okay, so that means we have to consider this one also. Now, if you think about like another consideration, the place of living, if we consider this one equal a set, so in this set, we can consider village and city maybe. Sorry. Village and city, this set. On that case, maybe the true side and here the false side. The true side, we will get the people of village and people of city. The people of village and city. And in false side, we will get the capital city. Is it new?
No, sir. It is the mirror of.
Okay, it is the mirror. Yeah. If we consider this one is number 1, this one is our number 2, this one is our number 3, then actually this one is the mirror of number 3. Okay, the true side, and whatever we got in false side, we got in true side here in this tree. So that means 4, the tree number 4 is the mirror of tree number 3. Okay? So that's why no need to construct this. Okay? No need to construct this. Similarly, if we consider some other like place of living equal village and capital city, this uh, composite feature, then again we will get that another mirror. Okay, another mirror. So that's why for 3 types of variable values we will get 3 different trees. Okay, 3 different trees. Similarly, if we consider about 4 features like village, capital city, and maybe metropolitan city also. Metropolitan city, there is 4 instances. So on that case, what we will get, maybe for the case of tree number 1, place of living equal village, if we consider, in true side we will get village, but in false side we will get city, capital city, and metropolitan city. Then for the 2, that is for the second tree, we will get in true side we will get city people, in false side we will get village, capital city, and metropolitan city people. And for our third tree, place of living equal capital city, true side we will get capital city, and false side we will get village, city, and metropolitan city. Okay. Similarly, we have to construct also, that is the fourth tree, place of living equal. This time, if we consider metropolitan city, metro city, that in true side and in false side we have to consider this is the true side and false side. For that, the metropolitan city people we will get in true side, and in false side we will get village, then city, and then capital city. Okay, so this is also new tree, so that's why we have to consider this one also. So this is our number 4 tree. Now think about our another tree line. If we consider place of living people, village and city. Okay, village, city. Village and city. So composite feature. So in such a case, this is true side and this is false side. We will get village and city in our true side, and then capital city and metropolitan city in our false side. Okay, this is also new, so we have to consider it. Okay? Similarly, we have to think about place of living equal. This time maybe you can consider village and capital city. So village and capital city. Okay, capital city. So this composite feature. Then in true side, we will get village and capital city, and in right side and false side, we will get city and metro city. Okay, this is also new. Okay, this is new, so we have to consider this one. So that means 4. This is 5, and this is 6. Okay, this is 6. And maybe we can consider a little more. If we consider about another one, place of living equal village and metro city, maybe village and metro city. So you will get in true side and in false side. In true side you will get village and metro city, and false side will be city and capital city, maybe. Is it new? In true side we will get village and metro city. Yes, it is also new. It is also new. So that means we have to consider this one also. Think about another one. So here you can consider about city and capital city. Okay, city and capital city. City and capital city. This composite feature. True and false. We will get city and capital city on left side, and right side we will get metro and village. Okay, metro city and village. So now we can see actually if we can closely observe these two trees. So whatever we got in false side, we get here in true side. Okay? And whatever we got in true side, we get it here in false side. So that means these two trees are just mirror. Okay, mirror. So we should not consider this one. Okay, now whatever other combinations we can try, we will get the mirror trees. Okay, mirror trees. So we can conclude that actually what we have considered. At first, we need to consider individually, okay, village, then city, and then capital city, and then metropolitan city. Then we have to consider this, that is village and city as a composite feature, then village and capital city as a composite feature, and village and metro city as a composite feature. Okay, so total 4 plus 3, 7. The 7 will be the possible our possible splitters. Okay, possible splitters. So that means if we have 4 features, then 2 to the power n minus 1, 2 to the power n minus 1 is, if we consider n equals 4, so 2 to the power n minus 1 is this one, then minus 1. Okay? So this will be the number of splitters. Number of splitters in case of categorical variable values. Okay, so 2 to the power n minus 1. So 4 features, 4 types. That means you will get 7. And for just only 3, the 2 to the power 3 minus 1 minus 1. So 2 to the power 3, that is 4. 4 minus 1 is 3. And for 2, we can say 2 to the power 2 minus 1 minus 1. In this case, we can see 2 to the power 2 minus 1 is 1, 1 minus, so the 2 minus 1 is 1. Okay, so that means for just only 2 types of categorical variable values, we will get one splitter. For 3 types of categorical variable values, we will get 3 splitters, and for 4 type of categorical variable values, we will get 7 splitters. Okay? 7. So we need to consider those splitters. So do you have any question or queries here? So I think no question from your side. Then we can maybe conclude our today's lecture on regression tree. Okay? Regression tree. So in this case, at first I have discussed about what is regression, when we have to apply the regression mechanism, and when we have to select the linear regression, and when we have to think about non-linear regression. And then we have discussed about the construction of regression tree with this example, and we have discussed here about how to deal with the feature with numeric values and how to deal with the feature with categorical variable values. And then we have constructed first the regression tree for depth 1, but as we have there is the threshold of depth 2, so we have expanded this tree. Okay? Expanded this tree, and then we have constructed this final tree. Okay? Final tree for regression, and after that we have a test set, and here we have considered about this one as a test instance, and then how to find out the answer from our regression tree we have discussed here. And then finally we have discussed about if there are many types of categorical variable values, then how to deal with those categorical variable values with multiple variables, not only 2 but 3 but 4. That's all in our today's lecture. Thanks everyone for joining this session. So that's end of our today's lecture. So I will consider the attendance for all of you. Okay, that means I assume that in online session all of you are present.
So next class will be online.
No, I think next class will be offline.
Yes, sir. Offline will be better.
Yes, sir.
Uh,
Offline will better.
yes, I am also there is think that offline class will be better. Fine. Okay, thanks everyone for joining this session. See you in our next class. Thank you.
Thank you, sir.